Okay, so we're back to our favorite model, the SklenkaSkis. But this time we're going to only be producing integer solutions. Now, I'm not actually going to build this model from scratch again because you just have to look at the SklenkaSkis video from the previous chapter. So this model is pre-built. Recall, we have an optimization problem here. We get a certain amount of profit from each type of ski we create. The deer crest has a higher amount of profit, but it requires basically more resources. We have a fabrication resource. We can't spend more than 84 hours fabricating. And we have a finishing resource. We can't spend more than 21 hours finishing. And we have a further constraint in that the deer crest, we must produce at least twice as many deer crest as Jordanelle. So deer crest, if we look at this line here, is greater or equal to 2 Jordanelle. And obviously we can't produce negative amounts of skis. Okay, so that's our model. And it's set up, as I said, the Excel setup we did the previous week. So I won't go through that again. You can go back to the previous video. So go to Data Solver. And we'll actually do the constraints from scratch. Okay, so we're optimizing total profit by changing these cells, the quantity produced. And we have certain sets of constraints. Basically, the hours used must be less than or equal to the limiting hours. Click OK. And basically the variables need to be non-negative. And then we have an additional constraint, and that's the excess deer crest. And this is just basically, I'll go show you the cell in a minute. This is enforcing the deer crest being twice as much as the Jordanelle. So this has to be greater or equal to 0. And then we're going to click solve. And we get exactly the same 5.25 Jordanelle and 10.5 deer crest. And you see here that this is just how much deer crest minus 2 Jordanelle, how it's greater or equal to 0. So basically, this number has to be greater or equal to 0 for this constraint to hold. So it's C14, deer crest, minus 2 times B14 Jordanelle, and when we run it in Solver, we make it greater or equal to 0. And just have a note here, our total profit is 945. That's our optimal profit. But you note here that these values are not integer values. We can't create quarter of a ski. So we're now going to go to Solver, and we're going to add constraints. And we're going to say that these guys are integer. And we're going to click OK. So basically, the constraints need to be integer. Now let's run it again. Sorry, I mean the variables need to be integer. Let's run it again. And we get the best possible integer solution. And in this case, we have 3 Jordanelle and 12 deer crest. But note the profit has gone down. The profit has gone down from 945 to 930. We could play around a little bit. We could have rounded the original solution, so we could have had 5 and 10, but that would have actually been lower profit. So this actually has done pretty well in that it's actually found the best profit for an integer solution. Now, let me just point out, this is a very small problem. Doing integer solutions of very large problems is difficult, and you're not always guaranteed to get the optimal solution. So Excel, I don't know exactly what the Excel algorithm does. There's a method called branch and bound, which is used to calculate these integer solutions. But calculating integer solutions for large problems will take a long time and is very difficult, just a proviso. But there we go. That's the integer solution for the SklenkaSkis.